part of the recent government investment of £270 million into quantum technologies, both John and myself are part of two of the quantum technology hubs that were funded. One of them is the Quantum Technology Hub in Quantum Communications, and
the other is the Quantum Imaging Hub, led by Glasgow, but we have a significant fraction down here, looking at ways of enhancing the accuracy of transmission of light through weakly scattering samples, through measuring distances, measuring with very little light in particular. We have a whole project which is looking at how quantum mechanics can be in fact sidetracked. We can use identical beams of light to measure the transmission through a sample which is placed in one of these identical beams more accurately than if we were using, say, a laser beam, which is the quietest form of light. A lot of the research will be working on how we cope with the very bright light of the classical communications and the very weak light at quantum level of our quantum communication systems. I've been in the business for some years now, and we started off doing this as a sort of game in the 1980s as a sort of very theoretical idea. It's now evolved into very close to market applications in some of the areas.
And I think it's John is maybe doing himself down a little bit there. John is one of the pioneers of this whole field, which did start back, I guess, in the 80s, and John has really pushed this field through. And the fact that we have this very big activity within the UK generally is down to John and his peers at the time, and that has allowed the UK government to invest approximately £24 million into taking it to the next step from the games, as John put it, into practical deployable technologies.
What inspired us originally was that we were playing with photons, we were counting photons, and then people said, well, isn't light a wave? So we were seeing waves and particles. So what gets me out of bed in the morning is if in the experiment that I'm doing, or if in the commercial device that I'm building, light behaves like a wave and a particle at the same time in that device. And in all of these quantum communication systems, that's what we're exploiting, is the wave-particle duality.
My background is both physics and engineering, and I've also been in and out of industry. And so this project is really a kind of accumulation of sort of my experiences of working in industry and working with state-of-the-art manufacturing technologies, but then being able to understand the quantum physics involved and apply these engineering techniques and principles to this area of quantum physics. I'm doing what my research group is doing, developing miniature microchip circuits where we can control and manipulate single photons of light within those microchip circuits. And that is what we believe will be the dawn of a new technology revolution, giving us new secure ways to transmit information, new ways to process information, so new types of computers where we can do simulations to simulate drugs and new chemical compounds, and it will also allow us to develop new types of sensors for high precision sensing.
The most exciting aspect of this research group is really the people, and is interacting with those people on a day-to-day basis. So I am inspired. As I walk down the corridor, I will have 5 conversations that are about different topics, about frontline research. Each one of those guys is excited, is desperate to discover new things and to turn them into engineered devices.
The strength of the research group here at Bristol, I think, is the breadth of expertise and the quality of the individuals. We're a research group that really spans right from fundamental physics right through to very practical photonic engineering.
I don't understand what I'm going to discover in a year's time. I'm forever challenged with another problem that may not have a solution. I may discover a solution and discover something completely new. So I'm always on the edge, and that's what's inspiring to me. It's the newness. It's not really knowing what the result of the experiment's going to be. I'm not really knowing the experiment until I get to it and saying, oh yes, that's what we need to do next.